Hi class, here's a chapter 6 bonus episode that's just going to cover trigonometric identities. After our chapter 6 quiz, I realized this is where we have gaps in our knowledge and I'd like to help fill them. So there are 4 basic algebra techniques to establish identities. So the first is to rewrite your expression in terms of just sine and cosine. The second is to multiply by a well-chosen 1. And you can multiply the numerator and the denominator by that well-chosen 1, right? Because that would be multiplying by 1, which keeps the equation the same. Next, you can write the sums of trigonometric ratios as a single ratio, i.e. it's just saying go ahead and add. If I have 1/2 plus 1/2, that's 1. Or 2/2. It's late in the day, folks. Okay, also we could factor, right? Remember how we factor quadratics? We find the factors of AC that add up to B. We can also factor out the greatest common factor. That's going to be pretty handy in these cases. So, first off, I want you to know it's almost always preferable to start with the side containing a more complicated expression. I do tend to work from left to right, but you do not have to do so. You always want to rewrite your sums or differences as a single quotient. Sometimes it will help to rewrite one side in terms of sine and cosine functions only. And the most important part is going to be to keep your goal in mind. Where am I going? Where am I trying to go? And as I manipulated one side of the expression, because we need to keep in mind where we're going, let's go ahead and keep in mind what we have on the other side, because we're trying to get to that point. So let's work through the 3 examples from the quiz that I gave you guys today, and then we're going to do 3 examples from worksheet of section 6.4. So we're going to be using all these different trig identities to solve these problems, and you will be given the trig identities on the exam. So this first quiz problem was secant theta minus tan theta equals cosine over 1 plus sine theta. This would be a great one to go ahead and write in terms of sine and cosine. So secant theta minus tan theta, my thetas are so lazy, okay, equals 1 over cosine theta minus sine theta over cosine theta. Okay, now I have 2 quotients with the same denominator. I'm going to go ahead and write these as 1 minus sine theta over cosine theta. Now, I'm trying to get it to look like this. So next step might be to multiply by a very strategic 1. I'm going to multiply by 1 plus sine theta over 1 plus sine theta. That gives me 1 minus sine squared theta in my numerator over cosine theta times 1 plus sine theta. Now, 1 minus sine squared theta, I can rewrite that as cosine squared theta, because we have this rule, right? Cosine squared theta plus sine squared theta equals 1. So if I was to subtract sine squared theta from both sides, I'd be left with cosine squared theta equals 1 minus sine squared theta, pardon. So now I have cosine squared theta over cosine theta times 1 plus sine theta. And one of those cosines is going to cancel out. So I'm left with cosine theta over 1 plus sine theta. The next example from our quiz today was 1 plus tan theta over 1 minus tan theta. And I want to rewrite my tangents as a cotangent. If I'm trying to get to cotangent, that's going to be like our first step, and it makes life easier to do it this way. So if I have 1 plus tan theta over 1 minus tan theta, that equals 1 plus 1 over cotangent theta over 1 minus 1 over cotangent theta. I'm going to rewrite these ones as cotangent over cotangent so I can add my numerators, right? We don't want to have a complex fraction. That's a fraction where we have fractions in the numerator and fractions in the denominator. So I'm going to have cotangent plus 1 over cotangent theta as my new numerator, and cotangent theta minus 1 over cotangent theta is my new denominator. Now when we're dividing, we keep change flip. So I keep the first fraction the same. I change from division to multiplication, and I flip my second fraction. As you can see, these cotangents, when I multiply across, are going to cancel. And I'm left with cotangent of theta, don't forget your thetas, plus 1 over cotangent theta minus 1 as desired.